Hello students, welcome to online course of Mechanical Measurement and Metrology. Myself Abhishek Trivedi from Mechanical Engineering Department at LJ Institute of Engineering and Technology. We are discussing measurement of the screw thread and gears. In the previous lecture, we have discussed the measurement of the effective diameter of the external screw thread by using the two-wire methods. Today, we are going to discuss the measurement of the effective diameter of the same external screw thread but by means of the three-wire method. So we have to measure the effective diameter by using the three-wire method. Now what is the basic drawback in the two-wire method? That suppose this is the thread profile. On the opposite side, this is the same thread profile. This is external thread profile. We have placed a one wire over here. We have placed another wire over here. The single side micrometer has been placed like this. The single side micrometer has been placed like this. So due to this particular setup, if we are going to increase the pressure over the micrometer anvil from both the end, there might some chance that the micrometer anvil will slightly move down. Here the micrometer anvil will slightly move in the upward direction. So we can say that the particular micrometer anvil may slightly rotate, or we can say it will start to rotate in a very slight motion. So this is the basic chance behind the particular two-wire method. To avoid this particular setup, what we have done, suppose this is our thread profile again. Then what we have done, we are supposed to provide a one wire over here, one wire over here, and let's say one wire over here. Here we are providing a micrometer with the support of the two wires, and here we are providing a micrometer anvil with the support of the single wire like this. So just because of providing the micrometer anvil, if we are increasing the pressure, there is no any chance, or we can say very least chance to make a momentum from any of the side. This is the basic concept why we are using the three-wire method. The figure shows the basic structuring of the three-wire method. As I have told you that in the three-wire method, what we are supposed to do, we are providing a one wire on the single side and the two wires on the opposite side with the setup of the micrometer anvils. If I have to measure the different dimensions, the very basic requirement to measure the dimension, that is the effective diameter. I have to find the value of the effective diameter. But to find the value of the effective diameter, we have to measure the dimensions over the wire, that is the M. We can measure the dimensions under the wire, that is we can say the value of T. This is the effective diameter that we are supposed to find, E. From this particular figure you can check what we are supposed to do. We are simply taking the cross section zoom view of this particular setup. So here the total dimensions under the wire, or we can say the dimension under the wire, this is the under the wire, let's say that is the value of T. The dimensions over the wire, that is the value of, let's say, M. The total angle, or we can say this is the thread angle, the value of thread angle, that is the theta. If we are deducting, or we can say if we are bisecting the theta, it becomes the flank angle. The flank angle having the value of theta by the particular wire itself having the diameter small d. This is the value of the pitch. We have discussed the pitch, that is the distance between the two crest points. This is the pitch. The distance between two root points, this is also the pitch. The distance starting with the one point, the same point on the corresponding tip, this is also the value of pitch P. I can say that this is the value of pitch P. If we are bisecting the particular setup with proper bisection, then this is going to be the P by 2. This particular distance, that is the P by 2. Further we are bisecting this particular, let's say BC, then the value of the BC, that is the P by 4. Fourth division of the pitch. The height difference between the line of BC to the end of the, we can say, crest value, that is the value of H. And the total height of the particular teeth profile, that is the capital H. This is the total height of the profile, capital H. Now we are going to discuss the basic derivation, or we can say how we can measure the value of the First of all, let us consider the triangle ABD triangle. Let us consider the triangle ABD over here the angle of triangle, that is a theta by 2. Suppose this is the right angle triangle. Then what is the AB, or we can say if I have to find the value of, let's say, sine theta. Again we have to find the value of sine theta by 2. Then what is the sine theta by 2? That is the opposite side, let's say AB upon hypotenuse, let's say AD. Make the AD as a subject of the equation. AD, that is equal to AB upon sine theta by 2. AB into sine inverse, that is the cos theta by 2. Replace the value over here. Now capital H, we have already discussed what is the capital H. Capital H, that is the total distance. I can say that this is the value of capital H. What is the capital H? We can write this. The capital H, that is the, again consider this particular triangle, the triangle DE. Let's say we are providing some notation, we are not providing M, we are providing, let's say, F. So consider the triangle DEF. This is the our value of theta. Then consider the particular EF. What do you mean by EF? Then EF is equal to, I can write this, EF is equal to capital of H. So I can write it as a capital H, or we can say EF is equal to DE cot theta by 2. Where what is the value of DE? We have already defined that the value of DE, that is the P by 2, half of the pitch value. So I can replace the DE as a P by 2, then it is known as a P by 2 cot of theta by 2. And what is the value of CD? This is the value of CD here. This is the value of CD. What do you mean by value of CD? Value of CD, that is the half of the H, capital H, half of the H. And I can write this, that the CD is equal to P by 4 cot of theta by 2. Now further, if we are increasing the derivation, what do you mean by small of H? What is the small h? Here this is the value of small h. This particular is known as a small h. So I can write this small h, that is the total length AD minus this bottom side CD. I can write this h is equal to AD minus CD. Replace the value of the AD and value of the CD inside the equation. Now what is the distance over the wire? We know the distance over the wire. Distance over the wire, that is the M. M is equal to E plus twice of H plus twice of R. This is the distance over the wire. Put the values of H and R in the main equation. R can be replaced by D by 2, that is the half of the diameter value. So I can write the total value of M, or we can say I can write the equation M, that is equal to E plus D 1 plus cosec theta by 2 minus P by 2 cot of theta by 2. If we are supposed to make E as a subject of the equation, then the equation can be reduced in the M and theta by 2 plus D, that is the diameter of the wire. M can be measured as in the micrometer, and whilst D, that is the wire diameter, we know the value of the wire diameter, and P, that is the pitch of the given thread. So guys, this is the basic equation for the 3-wire method. For the Whitworth thread, take the angle of theta, that is the 55, and the depth of thread is equal to 0.64 of P. Replace all the values in the main equation. You are supposed to find the, or we can say we are supposed to reduce the main equation dimensions over the wire. M is equal to D plus 3.1657 small d minus 1.605 P, where capital D, that is the major diameter of the given thread. And the same value if we are supposed to find for the metric threads, then we can replace the angle of theta, that is the 60 degree, and the depth of thread, that is the 0.6495 P. If we are supposed to replace the all values in the main equation, then M can be reduced as a capital D plus small of 3D minus 1.5155 of P. These are the basic equations for the metric as well as Whitworth thread. We can measure the value of the M practically and then compare with the theoretical values using the formula derived by above equations. After finding the correct value of the M, as we know the value of D, we can find out the value of the E, that is the effective diameter of the given thread profile. Now the last topic of the particular sub-part of the chapter, screw measurement, that is the based wire size, or we can say derivation of the based wire size, how we can select the particular wire as a based wire. As we have discussing the different thread profile like this, suppose, and if I have to make sure that I have to select a wire as a based wire, then what is the basic condition of the based wire? If the wire is undersized wire, then there is a chance that wire will getting inserted in the thread profile. If the wire is oversized wire, then that is a chance that the wire will not getting inside the proper setup. But if the wire is of the based size, then it will make a proper physical contact at the flank surface with the effective diameter line. So selection of this particular wire is known as the based wire size. This is the based wire size. Here this is the undersized wire, and here this is the oversized wire. And this particular size of the wire is known as the based size wire. Now to find the based wire size, now to find the value of the wire size as a based, or we can say the diameter, that is the based wire diameter, what we are supposed to do, we are considering a single wire system. Consider the triangle AOB, this particular triangle. We have to consider first AOB triangle having the right angle over here, and consider the another triangle, that is the triangle BO. Suppose the point has been given as a, let's say, C dash or C. So BOC you have to consider. The distance between the two creased value, that is the value of the pitch, or we can say this is the value of the pitch. If we are bisecting the pitch, the distance will be known as the P by 2, and if we are further bisecting the value of this, we are supposed to find the value of the P by 4. So I can say that the distance AB is equal to P by 4. E, that is the effective diameter under the pitch line. Now the based wire is the one which makes a contact at the pitch line, or we can say on the effective diameter line of the screw thread. In other words, we can say that as shown in the figure, the value of the OB, that is the based wire size, which is perpendicular to the flank portion of the given thread profile, and it becomes the based wire size. Whatever the wire which make a proper right angle to the flank profile, the wire itself is known as the based wire, and the diameter of the wire is known as the based wire diameter. First of all, let us consider the triangle OAB. We have to consider this particular triangle OAB. This is our considerable triangle. Here, this is the right angle triangle. This angle gonna be the theta by 2. This is our angle theta by 2. If this gonna be the right angle triangle, then this is the theta. Let's say point C over here. So in the very first triangle, we can say triangle OBC. This is theta, this is 90. Then this particular angle, we can say that the angle BOC, that is the 90 minus theta by 2. I can write this as 90 minus theta by 2. Now the same, suppose the triangle, we are considering the triangle, another triangle, that is a triangle, let's say ABO triangle, where this is the right angle triangle. We can say here the angle is 90, here the angle is 90 minus theta by 2. Then what is the angle over here? The angle, that is the theta by 2. So in the triangle OAB, sine of BOA, that is the AB minor upon OB, opposite by hypotenuse. If we are replacing the angle, I can write it as a sine 90 minus theta by 2 is equal to AB upon OB. Now make the subject of the equation OB. OB is equal to AB upon sine of 90 minus theta by 2. As we all know the basic mathematics, sine of 90 minus theta by 2, that is the cos theta by 2. Replace the value of the cos theta by 2, and 1 upon cos theta by 2, that is become the sec theta by 2. So I can write this OB is equal to AB of sec theta by 2. But we know what is the value of OB. OB, that is the radius of the wire, or we can say half of the diameter of the wire, where diameter becomes the based wire size diameter. So if we are replacing OB as a half of the diameter of the wire, so I can write it as a diameter of the based wire size DB is equal to twice of OB. We know the value of OB, that is the AB sec theta by 2. And what is the value of AB? We already discussed in the previous slide that the AB is equal to P by 4, fourth division of the pitch. So if I am going to replace all the values, I can say that the based wire size DB is equal to 2 times P by 2 sorry 2 times p by 4 sec theta by 2. If we are multiplying the 2 inside the equation, then dB can be written as a p by 2 sec theta by 2. This is the best wire size for the selection of the effective diameter, whether it is useful in the 2 wire or the 3 wire method, irrespective of the method of measurement, or we can say irrespective of calculation of the effective diameter by the 2 wire and 3 wire method. If we have to select a best wire, then we can select the best wire by using the equation dB is equal to p by 2 sec theta by 2, where p that is the pitch of the thread profile and theta that is the thread angle of the given thread profile. So guys, here we are winding our lecture. What we have discussed today, we have started with the 3 wire methods, and then we have concluded the lecture with the selection of the best wire by using the equation p by 2 sec theta by 2. Here the topic thread measurement has been completed. From the next lecture, we are starting our second portion of the chapter, that is the gear measurement. It is also very important parameters for the measurement of the gears, how the gears can be manufactured, how the gears can be measured, and how the which are the different parameters that we are supposed to measure for the mass production of the gears. Till then, thank you.